Hello everyone, welcome to this lecture. In this lecture, we are going to study about the fifth unit, which is about data structures. So here's some data structures. We have already taken a brief idea like list, right? So about list, we have already taken a brief idea in some previous lecture. But in this unit, we are going to study them in detail, right? So more on list. So the list data type has some more methods, right? Few methods we have already seen earlier. So if someone is new here and does not know what is a list in Python, so let me tell you that list is basically a sequence of elements, right? So here one collection of elements we store in list, right? They are represented in square brackets, and in list we can list is mutable, so that means we can change the elements, okay, and that we will see a practical proof of that using these methods, right? Okay, so that is what is list. And also list can have heterogeneous elements, that means multiple types of data can be stored in a list, okay. So that is a brief idea about what is a list. All right, so here on list, what are some common methods which we can apply, that we are going to see. So here one list is there, and based on that we are going to see all the methods and also see it practically that how it is exactly working, right? Okay, so the very first method we are having is list dot append and then x, right? So what it will do, so already we are having some list. In that list, one more item will be added at the end, right? So this you have to keep in mind, add an item to the end of the list, okay. So any other position is not possible here. If you are using the append method, then this element x will be added at the last, okay. And it is very equivalent to writing this particular statement. So if this also you are writing, that is a is the list name, let us say, right? So a of length of a, right? Length of a is the last position completely. So there and then colon is there, and after that, so this is basically the slicing which has been performed, right? So it means that starting from the last position, right? That means if a is having three elements right now, so here length of a is 3, right? So 3 to the end, so which is basically 3 only, right? So at that 3 location, this element x will be stored. So that is the basic meaning of this particular statement. So let us see it practically, that how this append works, okay. So I'm using this Replit, which is the online IDE for Python, so you can also use this. Okay, so first of all we have to invoke the interpreter. So you can write here Python 3 and you can do it just like how in terminal we used to do, right? And after this you have to create one list. So let us say I'm creating the list as list is equal to, this is how you have to write, and after this in square brackets you can write whatever elements you want, okay. So I'm writing here 1 2 3. You can write heterogeneous elements also, but mostly we go with some well defined collection only. So let us keep it 1 2 3. So it has been done. Now if I just write here list, the list will be printed, right? So right now we saw the append method, so let us use that. So list dot append, if I write, and here if I give the element as 4, in that case it has got appended. So you can just print here list again, and now you see 1 2 3 4 is getting printed, right? So here only the thing is that here only one single element you can add, not more than that. So if you want to add the elements like this, that list dot append, after that 5 comma 6 comma 7, three elements we will add together at the end, so this is not possible and you are going to get error, okay. So I hope it is clear. Now one more thing was written, right, that it is very similar to, so let me show you that particular statement also. So here what is the name of the list? It is list itself, right? So list is equal to, here what you have to write, list of, and then inside you have to perform the slicing, okay. So what is the length of the list? So I will be writing len of list, right, and then I will put here colon and then this square bracket, right? Okay, so actually I have to write it in this way, that is list, right? Here it has to be done. So list of length of list in this manner. Then I will put the colon for the slicing part, and here I will write that what element I want to insert, right? What I want to append. So here let us say now 5. Okay, so here now you can understand from these mistakes, you can keep these things in mind, that what you should do and what you should not do. Like here directly 5 has been entered, right? So entering 5 means 5 is just a literal, right? It is a numerical value. So numerical value cannot be assigned like this. You have to assign, can only assign an iterable. That means it itself has to be a list or any iterable object, right? But 5 is not iterable, and that is why you can see in the documentation that here like this square brackets are used, right? So from here, so it means that it is a list, right, where one element is there. So that is what you have to follow. So in that case, you have to write 5 in this manner, right? So from this, you can understand that you cannot do like that. Okay. So now if I print list 1, 2, 3, 4, 5, all the elements are appended. Okay. So this was the append method. After that, we can see the extend method. So list.extend, and here some iterable you have to pass. That means some iterable object, right, on which we can iterate by some loop and all. Okay, so what it does, it extends the list by appending all the items from the iterable. So in this iterable, whatever you are passing, from that it will take all the elements, and those elements will be appended to the list, which is this one, right? So to this list, the elements will be appended. Okay. Again, it is equivalent to the same thing. So if you see these two, statements, these two statements are same. That means at the last position we are adding, but here we were adding just a single element, and here what we are adding, we are adding the iterable, right? So this is only the difference. All right, so what we can do, we can write here list dot extend. Okay, and then here we have to pass some iterable. So here also, if you write directly any directly literal value like just 6, 7, it will not be allowed. Okay, so inside some iterable object you have to write. So let us say 6 comma 7 comma, okay, 2 comma 4, like this. So some elements we can add like this, and then you can print the list, and so all the elements are added here. So this is your extend method. Okay, after that we are having list.insert, where two parameters you have to pass, I comma x. Okay, so insert an item at a given position. So this I is basically the index. So at which index you want to insert, that position you can enter. Okay, the first argument is the index of the element before which to insert, right? So a dot insert 0 comma x, if you are writing, then that means at the 0 location, right, x will be entered, and rest of the elements will be shifted back. So inserts at the front of the list. Okay, and a dot insert length of a comma x, if this is what you're writing, this is equivalent to a dot append, because where you are inserting at the last position, which means basically you are appending. So it is just different ways of doing the same task. Okay, append you can use, or maybe extend you can use in this manner. Okay, so for doing the same task you are having multiple ways, but otherwise the general task of insert is at any random position you can insert the element, which is not possible with the append method. Okay, so let us use this insert. So here list and then dot insert. Okay, and after that what we can do here, we can add in position 1, right? In position 1, let us say I'm adding 10. So after this I can print list, and now you see at position 1, so this is at 0, then 1, right? So at 1, 10 is inserted, and rest whatever elements were there, they are shifted back. So this is how it works. After that we are having list dot remove of x, right? So it removes the first item from the list whose value is equal to x. Okay, so that means list is there. Now it can have repetitive elements, right? But whichever is the first element which is matching there, that will be removed. And let us say that element is not present only, then what it is going to remove? Nothing. In that case it will throw value error. Okay, so let us check that. So let us say if I am writing here list dot remove. Okay, and here if you notice, this is my current list, right, the latest one, and here here 2 times 2 is present, right? So let me remove 2. So list dot remove 2 if I write. After that, if I print list, then you see which 2 has been removed. See, after 10, this 2 is there, right? Here, but after removing, what is happening? That first 2 got removed. So 1, 10 and then 3 is there. But whatever that later 2 was there, it is still present here, right? So that is the meaning. So if you're writing list dot remove, then the first occurrence, wherever it is there, it will be removed. Okay, so I hope it is clear. And let us say the element is not present. Let us see the example for that also. So list dot remove, you can write, and then let us say I'm writing here 20. Now 20 is not present in the list at all. Okay, so in this case I am getting value error, right? And it is saying list dot remove of x. So here x is 20, right? So that x is not in list. That is what is the message. All right. After that, we are having list dot pop of I. Okay, so what it will do, it removes the item at the given position in the list. So in this I index, some index you will provide, some position you will provide, right? So in that position, whatever element is there, that will get removed, and also it will return that. Okay, so whatever element is getting removed, that will get returned. So if no index is specified, let us say if any index you're not passing here and this is empty, in that case it will work like so. This a dot pop removes and returns the last item in the list. Okay, so if any index you're not passing, then the last will be removed. Okay, now the square brackets around the I in the method signature denote that the parameter is optional. So here if you notice, here I is written, but around that square brackets are there. So what is the meaning of the square brackets? It is not a part of the syntax. This square bracket means it is optional. So I is optional, it is not necessary. Okay, all right. So not that you should type square brackets at that position. Okay, so you will see this notation frequently in the Python library reference. So if you read Python library references and all, there also you can find such notations and all. Okay, so let us use this list.pop, right? So if I'm writing here list.pop simply and not passing anything, then in that case, the last element which was present here, the 4, right? So that 4 is getting removed, and also it is getting returned, and that is why 4 is printed. Otherwise, in earlier methods, nothing was returned, so it was not printing also anything after removing or appending, whatever, right? Okay. Now let us say if I mention the index, so list dot pop, right? Now in list dot pop, if I write here 2, so that means index 2 it is, not element 2, right? So index 2. So at index 2, if you see here, it is having 1, 10 and then 3 is there, right? So 3 is present in index 2, so that is getting removed. So this is how this pop works. Okay. After that, list dot clear is there, so it removes all items from the list, which is equivalent to delete. Okay, so this I will be performing at last after doing everything, because otherwise if I use this clear right now, the list will become empty. Okay, so we can see that at last. So let us first of all look at this list dot index. Okay, so here what is there? List dot index. Here you see x is not written inside square bracket, so this is compulsory. Okay, so basically what it does, it returns the index of this element x. Okay, and otherwise this start and end, these are optional. Okay, that is why it is written inside square brackets. So if you want, you can use it. So what it does, basically it returns 0 based index. 0 based index means the list starts from 0, right? So 0, 1, 2, based on that it returns the index in the list of the first item whose value is equal to x. So here also, if multiple occurrences are there, wherever the first match is there, that index will be returned. If it is not present at all, you will get value error. Okay, now the optional arguments, which are start and end here, right, are interpreted as in the list, as in the slice notation, and are used to limit the search to a particular subsequence of the list. That means in a particular subsequence, if you want to check that in that particular part what is the index of the specified element, then you can specify start and end. The returned index is computed relative to the beginning of the full sequence rather than the start argument. So whatever index will be returned, that will be with respect to the entire list and not with respect to the start argument. So let us see what we are trying to say here. So here, let us say if I am writing list.index and index of what, right? So let us say index of 4 I want to check, like this. Okay, so it is returning 2, right? Actually, if you print the entire list, let us see that what all elements are present. So these are the elements right now present in list. Okay, and out of that, what I printed the index of 4, right? So where 4 is present at this location, which is 0, 1, 2. Okay, all right. Now let us say if I specify list dot index of 4, and then let us say start and end. If I specify, so start and end, I'm giving 5 comma 8, like this. Okay, right? Okay, so actually we can give from 3, right? So from 3 to, let us say, 6. This is what is there. Okay, so now so I am finding the index of 4 only, but from where? From 3 to 6. Now where is 3 starting? 3 is starting from 5, right? And 6 is there, so 6 is excluded, and that is why 5, 6, 7. So this is the subsequence in which 4 will be searched and that index will be returned. Okay, but in this particular subsequence 4 is not present only, right? And that is why it is saying that 4 is not in the list. Okay, after that, one more thing you can check here, as the point was written, that is, let us say if I'm writing list dot index, and here I'm writing 2 comma 4. No, actually I want to search 4, and start and end is 2 comma 4. Okay, all right. Now you see, so I'm searching for 4, right? What is the index, and then in which subsequence? From 2 to 4. So what is 2 to 4? 2 to 4 is this, right? So 2 to 4, which is 2 and 3. So basically this is the particular subsequence which will be captured. Okay, now in this subsequence, what is the index of 4? So still it is returning 2, because 2 is the index which with respect to the entire list, right? So it is not that the subsequence is having only 2 elements, so and 4 is the first element in that subsequence, so it will return 0. It is not the case. It will return the index with respect to the entire list. So this was the point which was mentioned there. Okay, so I hope it is clear. After that, list dot count is there of x, return the number of times x appears in the list. Okay, so actually here we are having just every element is present actually one time, so we can just add some more elements here and then we can count it. Okay, so let us say 1, 1, then 4, 5, and then 10, then 1, and then 1, like this. Okay, so if this entire thing I extend, now if you see the entire list, so this is my entire list, right? Now here if I want to calculate, then I can count list dot count, and let us say I want to count 4, that 4 is appearing how many times. So it is printing 2, right? You can count 1, 4 is present here and the other one is present here. After that, list dot count, let us say 1 is present multiple times, so it is present 5 times. Okay, now let us say if I want to count 100, which is not present, so for that, let us see what will happen. So it is printing 0 because it is not present. So I hope it is clear. After that, we are having list dot sort. So this is these are actually optional. You can add, or even if you can, if you want, you can skip this. Okay, this entire part. So it sorts the item of the list in place. In place means in the same list. Okay, the arguments can be used for sort customization. So here whatever arguments are there, that is for sort customization, that if you want to sort, in what order you want to sort, how, with respect to what, so such kind of things you can specify in these arguments. So for that detailing, if you want, you can go to the sorted method and you can check there, but otherwise I will be teaching that in some later topic, okay, in some later lectures. And but otherwise, let us see that how simply we can do that. Okay, so you can see this list which is not sorted at all. Okay, so if I directly write here list dot sort, in that case okay, so list dot sort, if I do, it has got sorted, and then if I print this, then as you can see the list has been sorted like this. Okay, After that, I can also write here list dot sorted, and then let us say I am writing reverse as it is written here, right? Reverse. So reverse is equal to false is written, right? But if I write here reverse is equal to true, that means I am saying that in the reverse order you sort it. That means it will be sorted in the descending order. Okay, so as you can see, it is sorted in descending order. So reverse equal to false means don't reverse. That means keep it in ascending order, right? So that was the meaning. So this is how you can sort the list. All right, after that L dot reverse is there, so it is just for reversing. Okay, so you can just write here list dot reverse, and then you can print the list, and so it has been reversed, right? It is not about sorting, it has got reversed. Actually the list was sorted, so it is printing like this. Okay, after that list dot copy is there, so it returns a shallow copy of the list which is equivalent to this. Okay, so if you write like this also, the list will get copied in the similar way. So let us see that. So let us say if I am writing here list 2 is equal to list dot copy. So in this case, now if I print list, then this is what is getting printed. If I print list 2, then also exactly the same thing is printed. Okay, and shallow copy means what? That they are having different copies completely. Okay, and how can we check that? We can check that by printing the IDs of the list. So here ID of list is this, and ID of list 2, if you print, then that is some other number, right? Some other number. So the addresses are different, so that means they are having completely different copy. Okay, so if I make any changes in one list, it is not going to affect the other list. That is the meaning. So let us see that. Let us say if I am writing list dot append, okay, and I am appending, let us say 200 in the second list. Okay, done. Now if I print list 2, it is printing along with the last element, which is 200, which has been appended. But if I print list, only list, right? So it is not getting affected by the operation which I have performed in the list 2. Okay, so that is the meaning of shallow copy, that both are having their own copies, and one list is not going to affect the other one. Okay, all right, so this is how you can copy them. And after that, this one more example, I have shown the example from my side, but otherwise here one more example is there where they have taken one list, and on that they have applied all the some of the methods, right? Index, count and all, and based on that respective outputs has come. So definitely it is highly recommended to you as well that you take some list and apply all these methods and see what kind of output is coming or not. Okay, and if you face any difficulty in doing that, or maybe some such kind of output you are getting which you are not understanding, then you can comment and I will try to clear your doubt. So this was the common methods which we use along with the list. Okay, now here few points are there which you have to remember. The first one is, you might have noticed that methods like insert, remove or sort, okay, that only modify the list have no return value printed. Okay, like for example when we were doing it, okay, like even for append, okay, like I have appended list 2 dot append 200, right? But it did not return anything, and that's why nothing was there on the output screen. Again I had to write list 2, then output came. Okay, but again for pop, if you see, like here pop is there, so list dot pop 2, in that case automatically output is also getting printed. Okay, so some methods are there which is not going to return anything, and in that case the default return value is none, right? So if I write here list dot remove, okay, list dot remove 5, okay, so it is not returning anything, right? It did not print anything. Now if I print here like this, print list dot remove, or maybe you can try with insert as well. Okay, so if I am writing here 6, in this case it is printing none, right? So because they don't return anything, so the default value is none. So this is a design principle for all mutable data structures. As I said, list is mutable because we are able to make changes in that. We are appending, we are deleting, removing, right? So it is a design principle which is used in Python, that if mutable data structure is there, then wherever we are mutating it, that means we are changing the structure, in that case nothing will be returned. Okay, so default value will be none. And another thing you might notice is that not all data can be sorted or compared. We have done comparing, sorting we have seen, right, by the sort method. So here one point is there that all kind of data cannot be sorted. Here I performed sorting on which kind of list? On such a list which is having only numbers. So the numbers are comparable in itself, and that is why we could sort, right? But let us say if I'm having this kind of list where one element is none, then hello, then 10, because as I said, list is heterogeneous. So different types of elements can be present here, but in that case we cannot sort it, because hello and 10, these values cannot be compared. Again none, this value cannot be compared with anything, right? Because none is bigger or 10 is bigger. How can you say that? Okay, so they cannot be compared, and that is why it cannot be sorted also. So the list will remain like this. Also, there are some types that don't have a defined ordering relation. For example, 3 plus 4j. So these are your complex numbers, right? So for complex number also, we cannot compare it this way. This is like not valid in maths, right? So that is why even if these elements are there in the list, we cannot compare and they cannot be sorted. So always remember, if you're using such kind of methods, please keep in mind that which kind of elements it is having, and then based on that, sorting or comparison are possible or not, right? Okay, now here one method was remaining, which is the clear one. Okay, so I will show that and then I will end the lecture, and then in the next lecture we will be studying about using list as a stack. Okay, all right, so here let us apply that is list dot clear. Okay, so if I do this, in that case the entire list will be deleted, right? It removes all the elements. So if I print here list, in that case nothing is printed and this is completely empty. So this is the proof that if you are using clear, the entire list gets cleared. Okay, so this was overall about the methods, common methods which are used in list. The next unit we are going to study in the next lecture. Okay, so I'm ending this lecture here. Thank you.